Did you know that some quantum concepts are simpler than you may think? To start, let's look at one of the foundations of quantum physics, electrons. Electrons are subatomic particles that have certain properties to differentiate them from each other, and these differentiations are known as states. Electron states can get complicated, so for the purpose of this explanation, we will represent electrons as either being in a state of black or white. And now we're ready to get into the real topic of the video, superpositions. Essentially, superpositions are a state of probability. Weird, right? If an electron is in a superposition state, that means that it has a chance of being in one state or the other at the same time. Imagine we have a superposition consisting of a black state and a white state. In this example, the electron would have a 50% chance of being in a black state and a 50% chance of being in a white state. In this next example, our superposition state consists of 3 black states and 1 white state. In this case, there is a 75% chance of the electron being in the black state and a 25% chance of the electron being in a white state. But how do we know what state the electron is actually in? Well, it's more strange than you may think. If you try to look at the state of an electron to measure it, the superposition state is collapsed. The electron is forced to choose one state based on the probability of the superposition. You can think of it like flipping a coin. While in the air, you know that it could either be heads or tails with a 50% chance of either. When it lands, it will only be one of the two options. But it doesn't end there. Superpositions can also be applied to multiple electrons. Imagine we have 2 different electrons in the same superposition state. In this superposition, either both electrons are in a black state or both are in a white state. What this means is that if we were to separate the 2 electrons and then measure one, we know the outcome of the other. If electron 1 is measured to be in the white state, then according to the superposition, electron 2 would have to be in the white state as well because there are no other options. In other words, the fate of one electron is linked to the other. This is quantum entanglement. Here's an exercise to try out what we've learned. Take 2 coins. These will represent electrons. Tape the 2 coins together so that the head side of one is facing the tail side of the other, and then flip the coins. The coins would be in a state of superposition in the air, and when they land, you have seen the result and collapse the superposition of the coin on top. Because the coins are taped together, they are entangled, so you know what side of the bottom coin is face up even though you haven't looked at it. Thank you for watching, and I hope you enjoyed learning a little about quantum physics.